Hi guys, today we're going to talk about proportions of areas and volumes. So here we've got two boxes. This one's 16 by 6 by 8. This one's 8 by 3 by 4. So the first question is here, what is the ratio of the sides of these boxes? Well, if I take these two sides, they correspond to each other. I take 16 over 8, which is 2. And then I've got 6 over 3, which is also 2. And I've got 8 over 4. That's also 2. So all these have a ratio of 2 to 1. Okay? So this box is twice as big as that box is over there. Okay. So now the question is, what is the ratio of the surface areas of the two boxes? Well, you might say, hey, it's twice as big because this box is twice as big. But let's actually calculate the surface areas of the box. So the bigger box has a surface area, let's see, it's going to be 2 times 16 times 6 plus 2 times 16 times 8 plus 2 times 6 by 8. Okay, so what does that come out to be? 16 times 6 times 2, that's 192, plus 16 times 8 times 2, that's 256, and 48 times 2 is 96. And so we'll just add those together, and we're going to get 544. And that's in square centimeters. Okay, now, if the ratio is 2 to 1, and you were thinking, oh, this is going to have half the surface area, well, then this should be half of 544, which would be what? 272. So let's calculate its surface area. So that's going to be 2 times 8 times 3 plus 2 times 8 times 4 plus 2 times 3 times 4. Okay, so that's going to be 24 times 2, that's going to be 48. And that's 32 times 4, that's going to be 64. And that's 12 times 2 is going to be 24. And we add those up. And we get 136, which is not half of the other one. So what ratio is it? Well, we can take 544 and divide that by 136, and we get 4. Okay, so the actual ratio of the areas is actually it should be 1 to 4. Okay, so this one is 1/4 the area of that. Now, why is that? Well, because when we doubled the size, or when we took this and made it half as big, we didn't make it just half as big this way. We made it half as big this way as well. So if you look here, 8 by 3, I could fit 2 of those right here. Okay, and then I could put another 2 of those on top. So there's 4 of these on the front of these. There's going to be 4 of these on the side, and there's going to be 4 of these on top. Okay, so the area is 4 times less, or 1/4 as much. Okay, what about the volumes? Well, we can kind of see that from the same picture. Okay, this box is actually this box right here, and all these boxes are the same. How many boxes are there? Well, there's 1, 2, 3, 4 on the, or 3, 4 on the bottom, and there's 1, 2, 3, 4 on the top. So there's 8. Okay, so that the actual ratio of the volumes is going to be 1/8. Okay, so let's calculate that just to show it. Okay, so the bigger box here, the volume is going to be 16 times 6 times, what was the other dimension? 8. And then the volume of the smaller box is going to be 8 times 3 times 4. Okay, yep, 8 times 3 times 4. So, 8 times 3 times 4. This one has a volume of 96 cubic centimeters. And the other one is 16 times 6 times 8. That's going to be 768 cubic centimeters. And if I take 768 and I divide that by 96, I get 8. Okay. So here's what we did. In summary, we took the box and we made it half as big. That made the edges half as big. Okay. It made the areas 1/4 as big, and it made the volumes 1/8 as big. So how does that relate? Well, let's see. 1/8 is 1/2 cubed. And 1/4 is 1/2 squared. Okay, so we get this theorem that says if I do a size change of value k on an item, then the area will change by k squared and the volume will change by k cubed. Okay, so the two prisms below are regular. What's the ratio of the sides of the pentagonal prisms? Okay, so we find the two sides. The sides are 3 to 2. So this has got an enlargement. So K is going to be 3/2. Now, you need to make sure they're in the same units. These are in feet and those are in feet. So be careful of that. It'd be really tricky if you went 2 feet to 3 yards or something. Then it's not 3 to 2 anymore. Okay, what is the ratio of the surface areas of the two pentagonal prisms? Well, it's going to be k squared, which would be 3/2 squared, which would be 9/4. And then the ratio of the volumes would be k cubed, which would be 3/2 cubed, which would be 27/8. Okay, so volume is always going to grow faster than the edge lengths and the area. The area will grow faster than the edge lengths. Okay, they also shrink faster. So be careful of that. Okay, compare the areas of the two triangles below. So, and this should say the two similar triangles below. Okay, so I know that the ratio between the two is going to be 10 to 18, which will reduce to 5/9. Okay, so that's K. That means that the area, now that means this one is 5/9 the size of this one. That means that K squared is going to be 5/9 squared, which would be 25/81. Okay, so if I'm going from the big one to the small one, I'm going to use 25/81. If I'm going from the small one to the big one, I'm going to use 81/25. Okay, so I'm missing this length here, and I could calculate it, but let's just do this the other way. I know I can figure out the area here. It's half the base times the height. So that's going to be 11 times 10. That's going to be 110 square inches. Okay, I don't have to figure out what x is and then calculate the area over here. I can just go straight with this. So this is going to get bigger going from here to here. So I'm going to take 110 times 81 over 25. So I get out my calculator and I go 110 times 81 divided by 25, and I get 356.4 cubic inches. Whoops. No, square inches. It's area. There we go. And I didn't have to figure out x. Okay? Okay. Now, here I've got this situation. I've got a triangle here. It's a right triangle. It's got another right triangle inside of it. Now, what this does, so I've got a 90-degree angle here and a 90-degree angle here. So there's three triangles. There's the small one, the medium one, and the large one. The large one and the medium one both have a 90-degree angle, and they both share that angle right there. So by angle, the large triangle and the medium triangle are similar to each other. Okay, that means all their sides are proportional. Now, since this is a 90-degree angle, it also means this is a 90-degree angle. And the small triangle and the large triangle both have a 90-degree angle, and they both share this angle right here. So by angle, the small one and the large one are similar, which means all three of the triangles are similar. Okay, so I got to find x, y, and h. So here's what I kind of suggest that you do. You can take this triangle right here and copy it. I know you can't rotate it cool like this on your paper, but now the hypotenuse here is this side. This is 32. This would be x, and this would be h. And my 90-degree angle is right here. Okay. And now I've got a medium-sized triangle, which is right here. Okay, I'm going to take that triangle out here, rotate it around the same way. Okay, now I've got a 90-degree angle right here. This long leg right here is y. Whoops, let's make this green. Okay, the shorter leg is h, and the hypotenuse is 60. Okay. And then I've got the big triangle, which is this one right here. I can take that over here. I can take that and flip it. Okay, and that means that this side is 32. Oops. 32. There's my 90-degree angle. This is 60, and this is 68. Okay. Oops, I've already drawn these down here, apparently. Okay. Let's go ahead and... no need to have this on here twice. Okay, so I've got my three triangles here. Now, I know that the ratio, they're similar, so the sides are all proportional. So I know that 68 is to 32, as 60 is to h. So now I can solve for h. I know that 68 is to 60, as 60 is to y. And what am I missing? I'm missing x. So 68 is to 32, as 32 is to x. Okay, now I can go ahead and solve for x, y, and h. very simply. So x here is going to be 32 times 32 divided by 68. So let's get out our calculator and calculate that. 32 squared times 6, or divided by 68. It's going to be 15.05 approximately. We'll say 15.06. Okay. And now we can go over here and we can say, well, y is going to be 60 times 60 divided by 68. So 60 times 60 divided by 68. That's about 52.94. So there's y. Now you should check x and y. They should add up to 68. So that'd be 67, 68. Yep. Okay, it works. And now h is going to be 32 times 60 divided by 68. So 32 times 60 divided by 68 comes out to be 28.24 approximately. And of course these are all approximately signs because I had to round them. So make sure you got the approximate signs on there. And there you go. So I found all three sides. Okay, got a little worksheet there for you. Have fun with that. I'll talk to you guys later. Have a great week.